Hi, everybody. Welcome to the Microsoft Partner Showcase. I'm Brian Hitney, Solution Architect focused on data and analytics here at Microsoft. And today I'm joined by David Wright from HashiCorp. So in addition to the widely used infrastructure as code software, Terraform, HashiCorp also has a number of other management and security solutions. And so since every company is looking to integrate secure AI services in one form or another, this seemed like a great opportunity to check in with David and HashiCorp to see how they can solve some of these challenges. So, David, first, thanks for taking the time to join me on the showcase today.
Thank you for having me. Thank you for giving us this opportunity to talk to you and the team.
Great. Do you want to start off just by introducing yourself, your role at HashiCorp?
Sure. So I've been with Hashi now for nearly 5 years. I work through from in the APJ region as a partner SE and driving HashiCorp partner adoption throughout the region. Recently, I've moved into working with Microsoft specifically, and as part of the strategic technical team, looking at how working with Microsoft and Microsoft services, we can actually build joint go-to-market and value propositions that customers can then take advantage of. So leveraging things like AVM, so the Azure Verified Modules, or looking at integration paths with things like building intelligent apps, which is a sales play that we've built jointly together.
Great. No, thank you. That's a great introduction. And I know recently I read a blog post that you did, and we've talked about this a little bit offline. The number of customers, everybody is trying to integrate AI solutions. And I'd love to hear your perspective on what some of those challenges are that you're seeing from companies and partners integrating AI solutions.
Yeah, so I think there's the three kind of key elements with any of the AI solution challenges, which is like resource shortage, data classification and quantification, and obviously security. So when we think about how, from a HashiCorp perspective, we can tackle some of those challenges, automation is, particularly when coming to repeatedly building scenarios, means that you get scale and velocity. So you can take your small engineering team or your SOE, that center of excellence that has that AI knowledge. They can then build and establish workable patterns and repeatable deployable modules and leverage that across then the organization. So from an organization perspective, all they need to know is I need to put information into this point and I will get my outcome in from this point over here. So not having to understand, RAG architectures or, service deployments or service integrations. So being able to get that scale through it, and then looking at ways to then, from a security perspective, working with the security teams to say, how can you build security into that deployment inherently? So again, taking the burden of manual touch and manual labor away from that deployment and integrate security into the overall architecture from the using that whole shift left philosophy of doing it automatically and transparently.
Okay, yeah, that's I agree. I mean, that seems to be a big challenge, and I think is the ideal use case for infrastructure as code to automate and alleviate some of the burden of trying to have different teams work together to figure that out. Now, I understand at the upcoming Build conference, at least it's upcoming from our perspective, depending on when you're watching this, maybe it was in the past, but on the in the upcoming Build conference, you're going to be talking about some of this as well, specifically integrating Vault, Terraform, when building out OpenAI solutions. Is that right?
Yeah. So one of the things that we're doing at Build is obviously AI is a key theme that everyone's talking about, and so what we did was take a stance around thinking about how we can showcase this. And so there's the Red Dog Store application, which is a Microsoft demo app. And so what I did was take that philosophy around how that deployment, which integrates into an OpenAI or an Azure OpenAI search, and thinking about, when I looked at that app from an application deployment perspective, it's quite large. It's quite a lot of lift. There's quite a lot of knowledge needed to be able to understand that. And so how could I take and simplify that down to using just Terraform and run it with a few simple plan and applies? So if you understand, the basic construct of using Terraform, which is, you initialize it in your directory, you create a plan, and you then apply that as an infrastructure perspective. With those 3 simple commands, repeating that 3 times, you can build and stand up the entire environment and deploy the application. So Terraform is also now moving in, because of that Kubernetes platform component, moving into that ability to actually deploy applications and run that application criteria. So, simplifying, integrating the security, thinking about how we can bring PKI and certificate management. Fundamentally, obviously, most of a lot of the challenges with OpenAI is and any of the IR services are that they're API based. As soon as you get into API based, how do you secure that? How do you manage PKI, like certificates across that, certificate management, API endpoint? All of those traditional challenges that organizations have faced for many years have just been kind of heightened as they start to now accelerate into a new area where they have those challenges and then the challenges of understanding the new technology. So trying to simplify that, provide a way to actually tie those together, and looking at how you can simplify that deployment, simplify the understanding, and get security integrated into that at the earliest possible is kind of where we're going with the story for build and looking at that.
That's great. And I love that, because security first principle, and I admit I'm guilty of this, but a lot of times when we do demos, we tend to not focus on the security aspect, because there's oftentimes a lot of steps and a lot of things that have to happen that isn't the central point of the demo. So we often back burner that security piece to showcase something else, right? And to save time and to focus on a different aspect. So that oftentimes leaves customers with the question of, well, okay, but now how do I really do this if I were doing it in production, where I do need to worry about my PKI and where I'm going to store my credentials and my keys and everything else. So so without going through everything that you're going to demo and build, it would be interesting to look at some of the components of how this works, right? Maybe a little bit of behind the scenes and looking at some of the code.
Yeah, sure. So let me just share. This is for the hopefully everyone is familiar with Terraform, of course. But for those that aren't, this Terraform is made up of a set of documents. Within that construct, we have resources. Those resources are provided by a provider. So this is the element of bringing in, and we actually work jointly with Microsoft around several providers. So we have the Azure RM provider as defined here. This is where a lot of the resources are defined and have the construct of how you call them, and we'll take a look at what that looks like as a resource. And then there's also the Azure API, which is, if there isn't native support yet built into this, then you can actually use the raw API calls and actually use a YAML format to talk to the API endpoint. So from a services perspective, we can support any service that has an actual Microsoft Graph endpoint. And so we have support for all of the services very quickly. In terms of what we're doing here, we are basically starting to establish that ease of use. So from the overall outcome of the demo, we have our picture of what we're going to deliver. This is obviously the Microsoft Red Dog application. So all of these all of these elements, the elephant in the room, all of these elements need to be built and delivered from an application perspective. So which would usually be, something like a Kubernetes apply F from a directory. We can actually integrate that as part of this deployment. And as you say, I've been guilty of it too. How do we actually integrate and think about security in this? So we're using Cert Manager, we're deploying Vault into into our Kubernetes cluster, and we're integrating and creating certificates to deploy within that into the Kubernetes secrets, and actually using Cert Manager to push that out to our web endpoint. So when we run through that build demo, you actually see this run and build out, and the endpoint being is that the access for Store Manager, you have obviously Storefront and Admin. Admin has a certificate, a full-blown HCC certificate applied to it from our CA. And so obviously if we had a local CA that we imported into our browser support, or a corporate CA, you'd be able to have straight through transparent access. So and that thinking around how do we get security integrated into that element in that ultimately easy way of consuming. And so if we go back to the code and think about breaking this down in terms of where this fits in, so we do some basic elements around understanding, getting the subscription information. We can start to see this use of the resources. So this is from the Azure RM provider. We need to define our resource group. We give it some form of random name. So we create our localized random name. That way we can run this multiple times and you get a unique version every single time. So you can have this in the same account and have multiple use case. Again, that element of modularization. So in Terraform, we talk about using modules and module providers, which allows for this reuse. So you create code as generically as possible so that when you deploy it, it can be made unique using things like local factors or random integers to get a unique version, but the code never steps on itself. And then we do some clever things where we then tie our and provide information to and access for our Kubernetes and Helm providers. So this is taking information from our established Kubernetes cluster as we build it. So if we look at our K8 cluster up here, you can see that when this builds out, that stands up our environment and builds our AKS cluster, defines some of our pools and nodes and some of the system requirements. And because we're doing that within this single build construct, we can use that information and cluster ID to actually authenticate directly into Kubernetes and Helm. And so now we have an authenticated mechanism for our code to actually go and do Helm deployments. So again, now not only are we standing up our infrastructure components, but now we're actually getting to deploy specific app elements into that environment. So here you can see we are building and calling our Helm release for Vault. So this stands up HashiCorp Vault. So to be really clear, because I know there's a Microsoft Vault too, and it gets really confusing. But HashiCorp's Vault is our secrets management tool. So when we think about that in our diagram, that's this part here. So HashiCorp Vault is a secrets management and key management tool that allows us to then create and establish that certificate. So it can be actually act as a CA as well. So we can have our root CA there, and then all of our intermediate CAs generated from that. This then provides that as a certificate issuer for Cert Manager. So obviously we need to install Cert Manager, which we do here. So all of these elements leveraging, again, that generic thinking, looking at how you can pull that automation into it, allows us to then build up and stand and set criteria. So here we need to install our CRDs. We're turning Prometheus off because we don't want to track it. So we're actually even deploying within our environment some real defined controlled elements within our application deployment. And then we use traffic as an endpoint to get access to those, our node access for that store admin and store admin and store web front access. So this is the way that the app stands up. There's two paths. So you can connect using the native Kubernetes load balance address, and then there's the traffic one. So the two, you can actually compare between the two and see. And so once that has built through, we then get into kind of a little bit more of the application space components where we start to think about integrating our OpenAI. So this is all using a cognitive account, standing up those. And again, these are resources that are defined within those Azure RM provider. So these are all native resources that are defined within that element. We're pulling the resource in, we're giving it a defined name, and then we're putting localized inputs into that and specific structure to create that environment as per our diagram. And so as we go through, we then populate that information, and from an application perspective, we then look at deploying our app. And this is where the heavy lift really does come in when we're thinking about that application space. Normally, this would be covered by several like YAML, Kubernetes apply -f to a directory, and we've built that out. What we can do within Terraform, we have now native support for Kubernetes manifests. We also have directly service and resource support within these as well. So not just manifests, but we can actually then take that that service or a deployment. We can export it. There are we can either transpose that manually, or there is a tool which is called TF-K8s. That tool will actually take a service deployment and say output it into Terraform and build these manifests, which is how I did this. And so now you're actually taking that application code, transposing it into effectively Terraform infrastructure code, but you're actually working at the application space. And because this all builds through and runs within one construct, we now have the ability to deploy the entire application, the entire security components, all in a several sets of stage and building. And so that's kind of where the demo actually does walk through. I think from so one of the things I'd like to do here is actually show how that TF-K8s tool works, and potentially then answer any other questions that you have. All right. So what we have here is I've opened a terminal prompt within VS Code, handy little feature, and we've built our cluster. So this is all the environment is actually there. So if we actually look at our Kubernetes kubectl, can't spell. Right. So kubectl. There's our services. You can see that we have our store front deployed. We have our traffic endpoint. And if we went and actually connected to those, we have our Vault application deployed. So you can log into a local instance of Vault, all of those services there. But I think the interesting part is obviously if you do if we do a get service name. So if we do store admin, and then if we do get deployment, spell it wrong again. Oh my God, I've got so fat fingers today. We can actually you can actually start to understand that there's a deployment elements behind it. Now you can actually output this is dash pro YAML. And so now you're actually using the service that's up and created and running, and you're outputting that as a deployment construct. So within the YAML format, we've got the kind. Obviously, here is this is a deployment. If we go back to when we think about our other one, we have our service. So we can do the same thing here. 0. Having a bad type day. Again, here we've defined our service. We're giving it a link into our store name. We're creating a namespace. Interestingly, as a FYI gotcha, any of our app deployments and manifests, we need to actually tie them to a namespace. So a little bit of from a housekeeping perspective is when we build these, obviously some of the namespaces aren't necessarily defined because they are default. When you create these manifests using the TF-K8 tool, you can actually need to just go back and add in a namespace. There is a known Git issue around that, so actually there's just a workaround for a known issue. But in this, we now have that service. So if you were building these and you had those applications deployed that you then wanted to actually say, well, how can I get this service and use it to actually start using Terraform? You can actually push it into our TF-K8 tool. So I have the tool installed. We then strip out our output format, and we then create a and I spelled wrong again. Well, I'm not having a good type day. And then we create a name file. So for this, we could call it podcast.tf.
So that basically the TFK converts that YAML into the Terraform manifest.
Exactly. Yes. So this will now create that file. So what we have here is taking our service, and we've actually created our service as a manifest. And so it's not only has it actually read the YAML, it's actually created it as a specific resource. It's given it the service name, and now we've actually added in all of those specifics that we saw from that service element. So load balancer, we know what the app selector is, we've got the ports and all of those elements in it. And as you can see, the only thing that is actually missing is that default namespace. So here we would add in under that metadata and namespace, and you have effectively your service now created. So that TF-K8 is just a really useful little tool to actually move from a full YAML deployment into being able to integrate that into your infrastructure deployments, so that instead of doing there are lots of different workarounds of this. You can do like remote or local execs within Terraform, for example, which then runs as a code execution within your machine. Or if you then come out of it and run a script yourself to do it. But this way, you could actually export and deploy your application as you normally, with using the kube elements. So you can find a Kubernetes YAML folder, you could deploy it, and then you could export those and create a TF comparison of that, so that in your infrastructure standup, with a simple TF apply, you're now actually getting your full infrastructure ready to go. And so, these little tools and little things make it a lot easier from both a production perspective and also from a demo perspective. One of the things that we spoke about off camera was managing time in demos and getting things to actually work and be very clean and easy to present. This is a great way to show customers, here's how you can actually automate your here's how you can automate your deployment, here's how easy it is, here's how quickly you can get to point A, and then start talking about this is a full Kubernetes demo app stood up, running with all of your services deployed. You can go and jump straight onto those services immediately, and then have cert integrated and everything. So not only have you can show that automation saves a whole bunch of time, you can show the power of how that works with the application and the platform, but you can also show how security is built in. And so you're not spending time with customers talking about the fundamentals. You're getting to the really important business value discussions around this is really important, and being able to show them really quickly. So it's just a nice way to be able to simplify things.
Agree. And to have a way to reliably, you could take this all down and redeploy it, go grab a cup of coffee and be back, and you can recreate the environment very quickly and easily, which is great. And in fact, you've got all of this outlined in GitHub repo, which I'll put on the screen and in the notes in the description that will include as part of this showcase, so that people can, in addition to seeing the session at Build, also check out the repo and play with it. Yeah, to me, that's the best, is I want to see the demo, but then I also want to then go fork the repo and play around with it in my own environment. So this is a great opportunity to do that, for sure.
And like I said, the great advantage of the way that this has been created as well is that it is in a generic form. So if you run this, you can run this multiple times within the same subscription. So you can actually deploy this. If a customer says this is great, but I want to tweak this or look at this or play with this thing, you can actually customize it, go to another customer demo. They say, I want to look at this, stand up another version of it and do the same thing there, and still have the two in parallel within the same account. So it just offers a lot of flexibility that way. So yeah, definitely, it's a good little demo.
This is great. No, I appreciate David taking the time to show us all of this. This is really interesting, and I'm looking forward to your session at Build, and I'll include a link also to that session, so that regardless of if you're watching this and it's before Build, bookmark that and make sure you catch that session, or if you're seeing it afterwards, go back and watch it if you missed it. But we'll make sure we have that link in there. This is great information. Any closing thoughts before we wrap up?
Just a plug for Terraform Tuesdays. So we do run an internal Terraform Tuesdays. It's a global stand-up that we run once a month, and at the moment bi-weekly, moving to once a month. So please, if there is any Terraform questions that you want to learn more, there's some really good experts there. There's from a Microsoft perspective, it is a Microsoft internal only meeting, so you can bring along all of the secrets that you want, and we have a robust and open discussion around everything Terraform, HashiCorp security. So just a plug for that. Please come along, awesome. Join, build the community, and hope to see you there.
Great. I'll make sure I include a link to that as well. So check that out and bring your questions. I know I've had plenty myself, because I struggle with some of the infrastructure as code from time to time as I get through it. But thank you for taking the time, and thanks everybody for tuning in. And if you have any questions or feedback, make sure you leave that in the comments below, and check out the Build session. So David, thank you very much, and we'll catch you next time on the next episode of the Partner Showcase. Thanks for tuning in.
Thank you. Thanks, everyone.